Hey guys, welcome to our first workshop in which we're going to be exploring Python and math and how they both go together. This is our first session out of our 6 weeks workshop powered by the Eureka Institute. If you didn't already know, the Eureka Institute is a nonprofit organization that's dedicated to inspiring young students like you in science, technology, engineering, and math. And we do this by providing free opportunities, such as classes and events. This, of course, is an example of a class, and this is actually one of our many workshops that we've been running, and we hope to run a lot more in the near future. If you're interested in our programs and you like the experience you have with us today, you can check out the many programs that we're about to offer and we're currently offering at eureka.institute.xyz/programs. The link is on the slide over here. My name is Ayush, and I am one of the co-founders of Eureka Institute. I am also the vice president of the organization. The other two founders are Eugen and Zoe. They are both the co-presidents of this organization. I am primarily responsible for program management, and it's really nice to meet all of you here. Just a reminder, this is a recording of the workshop that already happened. So we already had these virtual workshops, and me and a group of other people are going to be recording these workshops and putting it on YouTube for people to be able to access online if they weren't able to attend these workshops. And finally, before we move on to the next slide, if you would like to be emailed when we have new events or classes, please join our mailing list, and the mailing list you can find at the bottom of any website page. So the teachers for this session, if you were present in our actual live sessions, it was me, Ashif, who is an events team teacher, and Calvin, who is another events team teacher. Both of them are going to be helping me out with this 6-week series. They're going to be recording 2 videos each as well. So yeah, we look forward for you guys to progress through these series. And if you have any questions, let us know in the comments of this YouTube video, or you can email us at eureka.institute.contact@gmail.com. So by the end of this program, we hope you guys will be able to acquire the following skills. You will definitely learn how to use Python to solve real math problems. You're going to learn how to work with variables, expressions, loops, and functions. You're going to learn logic-based reasoning and problem-solving skills. You're also going to be working on 3 to 5 mini projects over the course of this session and the rest of the sessions. You're going to be creating and presenting a final project as well. Now, of course, presentations were during the actual session, but we really hope you guys follow along and work on a project. And if you have any questions or need any guidance, you can definitely email us about that. Of course, you're going to need a computer, a charger, and since you're watching this on YouTube, this will be at your own leisure, but we hope you guys are dedicated and have your tools ready with you. If you want to take notes, you can definitely have pencils and a notebook, or whatever note-taking method you prefer, right? But if you really want to take notes, of course, you can pause and take some notes, because if that helps you learn, then that helps you learn. It's good for you. Now, before I move on, I just wanted to take a little note on a couple things on this slide. This is a lot of stuff, and if you're new to programming, guys, this may seem very overwhelming. Actually, this is the journey that all programmers take. They look at their lesson plan back when they were beginners, right? They looked at their lesson plan, they were like, how am I going to learn all this? Trust me, guys, this is what we're going to cover over 6 weeks, okay? So don't fret, don't get frightened. You will learn all the content, and you will master it if you put enough practice, and if you just watch through these sessions and do all the activities that we instruct you to do. That's the bare minimum you need to succeed in this class. And if you're dedicated, then whatever you put into this class is what you're going to get out of it. So I promise, although this looks overwhelming right now, you will definitely get to the point where you will be able to code this in no time, okay? So yeah, again, if you have any questions, please email us or comment down below. Of course, this is stuff we would be doing if this was a virtual session, but again, I will just give my introduction. My name is Ayush, and one interesting fact about me is that I love to travel. So today we're gonna, of course, get started with installing, or not necessarily installing, we're gonna be using an online platform. For Python, we're going to learn about what Python is in the first place, how can we incorporate math into Python, and going over some Python basics in general. So let's get started. So first things first, we're going to need some sort of platform to code on, right? Frequently, people call it an IDE, or an integrated development environment. You can download one and code it through, for example, Visual Studio Code or Anaconda or Jupyter Notebook. These are just one of the many examples, but for simplicity's sake, we're just going to use an online platform that Google itself offers to us called Google Colab. So what you guys should go and do is go to colab.research.google.com and create an account or sign in. You can use either your school or your personal account. That doesn't matter. To create a new notebook, you would click on File on the top right or on the top left, depending on how your layout is. Go to New Notebook in Drive, and that would be all to create your notebook. If you wanted to view your code history, you would also click on View and Execute Code History. However, at the moment, you probably do not have any code written since you just created your notebook, so you don't have to worry about that step right now. I will now walk you guys through these steps just so you guys can get a feel for how it looks like and follow along on your own. Alright, so now we're at Google Colab. This is the home screen you should see. If you see anything different, it's alright. Maybe it's another version or something else. Don't fret. All you need to look for is the top bar over here. Remember, click File, New Notebook in Drive. Okay? It should take you to a new notebook. And there you go. You should title it something meaningful. For the purposes of this session, I'm just going to name it Session 1. And we're going to do some projects on here in a bit. We were talking about the view executed code history. When you have code history, you can view this, but otherwise, we don't have anything right now. So that's all for getting set up. Trust me, it's that easy. We really thank Google for making all these little features for us so we can code without an IDE. However, I will advise you that going forward, if you decide to pursue coding as a career, you're probably going to have to steer away from these online coding environments and actually install your own software to code on. But for now, for learning purposes, I think this is the perfect platform to learn Python on. Very easy to run and very handy to use. And with that being said, we will move on with the session. Now to address the elephant in the room. What is this big plus symbol you see here, blue and yellow? Well, you might have seen something like this before. This is Python, right? This is the symbol for Python. Not that typical snake you think of when you hear Python. No. Actually, quite coincidentally, there's also a programming language named Python. And perhaps, hopefully, that's why you signed up. So, Python is essentially a simple and readable language that lets us turn our ideas into clear instructions that a computer can understand. And don't get me wrong, that's not just Python. That is literally all of the programming languages that are high level and can translate to English, right? However, Python is the most handy one because it's the easiest to write with, okay? Or in other words, in more formal terms, you could say it has the easiest syntax, okay? In Python, we write code almost like normal English, which makes it one of the languages that are easier to learn than others. And we can also solve math problems with this, which is the purpose of this entire course, and build real projects, which you guys will be doing. So yeah. So just a little bit on how Python code runs. It runs top to bottom, okay? And what does that even mean, okay? Well, for example, you have this statement. You have these three statements here. Print hello, x equals 5, print x plus 3, okay? So you don't have to understand what all of these do right now. I will explain it in a bit, sorry. I will explain what they mean in a bit. You do not have to understand what they do right now. The purpose I'm trying to get at here is, what does a programming language do? Programming language like Python. It runs top to bottom. That means, for instance, let me get my little highlighter on here, right? When you're saying print hello, okay? You're telling Python to print hello to the console or the screen, okay? It's not going to run this line until this top line is run, okay? It's going to run in order, meaning you can't say print x plus 3 before it prints hello, right? This is just how it reads. Just like you read a book, you read it from top to bottom, right? That's exactly how Python reads code and how it runs code. Okay? There's no setup or draw function. That basically what that means is that there's some languages like JavaScript that require a setup and draw function. You don't really need to know much about that. Just know that it doesn't involve these other logistics that other programming languages might involve. And another thing you should know is that the code executes once unless a loop is created, right? So when you print hello, right? When you're printing hello to the console or the screen, it's only going to print once, right? Unless you have some sort of loop. And loop is a word you might have heard, but we won't really go into that in this session. That's going to be content for another session. It's actually one of the most fundamental programming concepts, which again, we're going to go over later. But for today's purposes, just know that you can only run statements, or whenever you write statements, it's only going to run once, okay? So now to the syntax, okay? We're printing hello. Well, what's that doing? Well, based on the words itself, you could probably guess that it's going to write hello somewhere. Now, it's not actually going to print it like printer paper. No, it's going to print it to a console, okay? A console is essentially like a little environment that allows code to be outputted, right? How do you see what's going on the screen? Like, how can you verify that an output is happening, right? Well, you can print it to the screen. This is for you as a coder to see what's going on. Okay, so you can print hello, and it's going to output hello to you, right? This right here is called a variable, okay? And we will go with variables in more depth in this lesson, okay? But essentially, they just store values, and when you print x plus 3, you're just printing 5 plus 3, so you print 8. Again, if you're confused, don't worry. We will definitely go over this in the following slides. But this is just to tell you how Python code runs. So I just wanted to do a visual demo for all of you who aren't familiar with how print works. Well, we're just going to test it out right here. Hello world, okay? Some important things I want to point out before I click run. You have print. We have these parentheses around the text we have inside, and the text inside is surrounded by quotes. Very, very important syntax, okay? Make sure you follow this. When I run this code, it's taking a little while to run. And there you go. It printed hello world. So in the traditional sense, a console would be like a little box at the bottom of your screen. But, you know, this is an online integrated development environment or coding environment. So it's just going to print it underneath for you. So hopefully you guys have an idea now of what the print statement does, how Python code typically runs. Just for another demonstration, let me print something else. Just hello. Maybe another statement. Print, I like bananas. Okay? Print, I like apples. Okay? We have 4 statements here. How are they going to print? Do you think this one's going to print first? Do you think this one's going to print first? Do you think this one's going to print first? Or do you think this one's going to print first? Well, if you remember from the slides, Python reads code in order, just like you read books, right? So it's going to start with the first line. If there's no errors in the first line, it's going to execute it perfectly. Hello world. Then it's going to go to the second line. Hello. Then it's going to go to the third line. I like bananas. And then the fourth line, I like apples. So hopefully this gave you a good introduction into how print statements works and how order matters for Python. You can move this around, move this above this, and you just suddenly flipped the order on how your code is going to run. It reads just like you, from top to bottom, left to right. Now we're going to go over some basic Python syntax, right? And now a lot of beginners or people who are new to learning programming see this word syntax and get a little confused. Don't worry, that was me at one time, and I'll explain it for you right away. So whenever you think of syntax, you should think of what grammar means to you as English, right? In English, you have a certain rules or conventions that you have to follow, right? For example, if you're, say you have to combine 2 independent clauses, right? you can't just write the dog jumped over the fence and the dog fell on the ground, right? You can't say it without putting a comma, right? So let me actually write this for you. Okay, let me add a text cell. Actually, that's a handy feature. The dog jumped over the fence and the dog fell on the ground, right? Hopefully in English class you learned by now that you can't just combine these two sentences, right? That's incorrect. Now, us as humans can read that because, we are more intelligent creatures, but the computer needs it to be exact and accurate. Your English teacher will not accept this, right? You need a comma here because these are two independent clauses. They can stand alone. Now, the point of this lesson, of course, is in English. The point is to understand how syntax is so important for programming languages as well. For Python, indentation matters. Indentation is a concept of making sure your code blocks seem in place, okay? Now, that's some formal language. I'll explain it when we do some actual coding. So just know that how you start your new lines matter, okay? Colons and code blocks. Again, colons start code blocks, okay? So when we learn about if statements and while loops and for loops, whenever you put colons, that indicates that you're about to encase something within a loop. Now, these are really fancy words right now. Don't worry, we will explain all of it. These are just examples of Python syntax. This is actually an important concept, the third bullet point, the hashtag, okay? This is very, very important for comments. What are comments? Well, comments are probably another one of the most fundamental programming concepts in not just Python, in any programming language, right? And it's very ironic because I say it's important, but the computer doesn't even know that they exist. The computer is actually trained to ignore comments. Isn't that funny? Well, the reason for this is because programming is complicated. And when you write multiple blocks of code, sometimes if you're collaborating with someone, or say you just have to go back and visit your code like a week later, right? What if you forget what the purpose of the code was? It's so tedious to go look through code and try to understand what was the purpose of writing this code, especially as you go on in your future career to write more and more complex lines of code, right? Complex blocks of code. It's going to be so hard to scroll through all of that and try to figure out what you wrote. So, writing comments is wonderful practice. It is the best practice, and you should always follow writing comments. Let me show you how they work. So, of course, this is a very simple program, but just for the purposes of demonstration, I'm going to show you how effective comments would look like. So I'm going to put the hashtag, and I'm going to say print hello world. And I'm going to add comments for every one of them. Print hello, print I like apples, and print I like bananas. Now, when I click run, what do you think is going to happen? Let's see. Same thing, nothing changed. Why? Because the computer or the compiler is trained to see these hashtags and ignore them. Whatever comes after these hashtags are ignored. Very helpful tool in programming because it helps you as a programmer or other collaborators indicate what the line or block of code does. And to quickly go over the final two fundamental syntax requirements is that, first of all, spaces and tabs must match. Again, we're going to go over this. I'll show you some examples, or you actually will see it as we type out code. And Python is case sensitive, meaning whenever you write something, or for example, you write print, right? You cannot use a capital P, right? You cannot capitalize or lowercase anything that is deviated from what it actually should be, right? The print statement must be all lowercase, right? If you capitalize print, you're going to get an error. Let me show you. Say I put a capital P here and I run the code. Oh no, the first three ran. Remember, the first three ran, but the last one, I put a capital P, print is not defined. This just simply doesn't exist. The compiler cannot read this code. Another important thing I want you guys to notice here is that I made an error over here, right? A syntax error, that's what it's called, because I messed up the syntax or the grammar, right? So I made an error over here. But how come all of these ran? Well, that goes back to our other point about Python. It runs top to bottom, right? So if you look at this, it's running top to bottom, and you can verify that because it did print the first three. It just failed to print the last one, right? So I hope all of this is starting to come together, right? Python, whenever you run more scripts, you learn how so many things are connected, how you can see so many concepts about Python in play right here. All right, and now it is time to move on to variables, right? So before variables, guys, the only possible thing you could ever do with Python was just print things, right? Maybe some other basic operations, but really you can't really do much without variables. Variables are fundamental to Python. And I know I'm saying that for everything, but variables are probably the best invention in the programming world, right? Because they can help you do so many different things. And I'll explain why now, okay? What are variables though? Variables are just containers. Think of them as containers or boxes that can store things, okay? Variables are simply just boxes or containers that can store values. What type of values? Well, anything, okay? These values can be like numbers. For example, you see the x equals 7 over here. They can be text, or in programming you call text strings, right? Strings of text or characters. Speaking of characters, they can also be just single characters, single digits, right? They can be true or false values, right? And those are called Booleans. Now, the purpose of this is math, so we're not going to go too deep into Booleans, but Boolean values are just true or false. They can just hold, Boolean data types can only hold two types of values, either true or false. Okay? So these are variables, and what variables allow you to do is, again, they allow you to store variable values so you can use them later on. Now, hopefully you can see in this example, right? We're storing the value 7 into the variable x. So the important part to realize about this example is that what you're doing is you're naming the variable x, okay? Whatever goes on the left-hand side of the equal sign is the name of your variable. In this case, it's x, sorry. 7 is the value that you're assigning to the variable x, right? Let me turn on my laser pointer, okay? So it's easier to look at. So when people see the equal sign, they often get confused. They think of equations. They think of, like saying that x, or whatever you think of when you think of equal sign, it's a little different here. It's not that you're saying they're equal to each other. You're assigning the variable x to the value 7, right? That's an important distinction in programming. When you see equal, you usually think of something else that you learn in math. But here, all you're doing is assigning x to 7, right? So now the variable x is reserved. You can't use x for anything else, right? But what you can do is change it. You can go on and later change the value of x. Remember, Python reads variables top to bottom, right? So if you say x equals 7 and change it later and make it like x equals 10, now the new value of x is officially 10. All right? So the example here shows that you're setting x to 7, right? And then you create another variable y and set it to x plus 3. So logically, what you're doing here is you've already assigned x to 7. Now the computer reads the value of x as 7. So whenever you say y equals x plus 3, what the computer reads is y equals 7 plus 3. And what's 7 plus 3? Well, it's 10. So actually, the computer can't actually print 10 unless you write print y, or just a print statement in general, right? So if you only had these first two lines, it wouldn't really output anything. It would store it in its memory, but it wouldn't actually output it until you actually printed the y. So hopefully you understand the importance of variables and what they are. Again, I know they're confusing. For me, they were a very confusing concept at first. But if you ever need more help, again, you have resources And you can also definitely reach out to us through email or in the comments below. Now, I wanted to explore another example of variables in Python. So here, for x equals 10, let's take a look at this. So we have x equals 10 here. Let's actually take a look down here. So we have x equals 10, but we also set y equals to 10, okay? Again, the variables x's and y's, they're both our box, and they both have a 10 inside of it, okay? What you have to remember is that, okay, variables are boxes, but we set both of them equal to 10. Remember, each box is still unique. They're their own box, right? It doesn't matter that x is 10 and y is 10. They're both different variables, even though they store the same value. So whenever you print x, you print 10. Whenever you print y, you print 10. And although they are the same value, if you look into the memory, which we can't do right now, but if you were to be able to look into the memory of Python, you would see that they each are stored in a different place, right? Python in every programming language has a memory, and then they store variables like this, because where else would they go, right? They have to be stored somewhere. So if you were to look in the memory, they would actually be stored in different places of the memory, even though they output different things. So that goes to say, you can store the same value in different variables. That's not a problem, right? That's actually the purpose of variables. The purpose of variables is so that you can change your values, and whatever happens between two or more variables shouldn't matter, because they're able to hold all these different types of values, right? So the purpose of this example was just to show you that it doesn't matter what the values are, right? What matters is that you created two different variables, and now you have two distinct boxes that are being reserved or being held by your memory. For this next slide, I was actually talking about this before, and it's good to reiterate that when you assign a variable multiple times, it'll keep its latest assignment. For instance, you have x equal to 10, now you've just assigned the value x to 10, right? But now your next line of code said x equals 3, okay? That's interesting, right? Now, what the program is doing is, first, in this first line of code, it is reserving a space in its memory for the value of x, and it's giving it, for the variable x, and it's giving it the value 10, okay? Now, it's going to read the next line, and it's going to say x equals 3. What it's going to do is going to check, do I already have a variable named x in my system? And if it does, which it does in this case, because you already set x equals to 10, right? It's going to check its value. And whatever the value is going to replace it with what comes after this equal sign. So now, when you're trying to print x, it's going to output as 3. Okay, but now let's see this next line of code. You set x equals to 13. And now when you print x, it's 13. So, at this point of the code, all of this is forgotten. You never ever knew that x was equal to 10 and x equal to 3, right? This is fleeting. This memory is fleeting. You're never going to remember that you ever had a variable x equal to 10 or 3 whenever you replace it with 13, right? So that goes to say that whenever you're assigning variables, be careful. Whenever you're reassigning variables. So this is the first assignment, you're reassigning it here and here, right? Whenever you reassign it, be careful. You might lose the data in your first or previous assignments, right? You got to be very careful about the order you place your assignments in. Again, this is important because Python reads from top to bottom, left to right. I'd say now is about the time where the fun actually begins. You see the word inputs here, right? That means you, the user, is going to be interacting with the system. Isn't that really cool? Well, we're about to see how cool it really is by testing out some examples, okay? Well, what exactly is an input? Well, I already kind of described it. You're asking the user for data. And again, data includes numbers, names, words, and whatnot. Data can be anything, okay? This data can be used to store in variables, right? Now, hopefully you're seeing the importance of variables in programming, because what you can do is, for example, in this example you set name equal to input, what is your name? Don't worry about the syntax right now, I'll go over it in a second. But essentially, what the program is doing is taking an input from the user and storing that input in a variable called name, okay? now in the system, until and unless you change or reassign the variable name, you have a space in your memory that's forever attached to an input called, or you have a variable called name that's forever attached to an input, okay? So now whenever you reference name, it's going to print out whatever the user inputted. Isn't that really cool? Because now you can probably imagine what you can do with this. Now that you have access to the tool of input, you can probably create so many different games just with knowing about input, right? We're actually about to do an activity with inputs very soon. So what this is doing is, let me break down what input means. Input, essentially, it's going to open a little text box for the user, and on top of the text box is going to have a little prompt. That prompt is going to say, "What is your name?" And what we're doing after the user takes in the input and it gets stored in name, right, is that we're going to print the name. But what we're doing here is actually printing the name with a little word. Now, this is a fancy term called string concatenation. Concatenation is just a fancy way of saying joining together. What you're doing here is you're joining the string hello and the name that the user entered. Why is this useful? I mean, of course, you can probably print two different statements, right? But the problem with printing two different statements is that they're going to print in two different lines, right? And you don't want that to happen, right? If you wanted it to print on the same line, you want to greet the user with their name, you probably want to use this syntax, which is basically just combining hello and name, okay? I'll show you how it works in a second. All right, so back to our Google Colab over here. We're going to create a new code cell. If you're at Windows, you can also do Control MB. So I'm going to do that. And we're going to start coding our input, our first input. So we want to ask the user for their name, right? So we're going to make a variable called name. I'm going to set it equal to input. What is your name? Okay, and actually before I write the next line, I'm just going to run this. As you can see here, it gives you a prompt and it gives you a box to type in as a user. So I'm just going to enter Eureka, right? And what does it do? It does nothing. It just ran, okay? So you can see that it would store your name in the name variable, but you can't really verify that unless you actually print it. So let's print, first let's just print name, okay? We're going to type it again, and it just printed out Eureka for me. Now, to the concept of concatenation, what you can do is you can print hello, comma name, and what it should do for you is print hello Eureka. I noticed it put an extra space there. And boom, it printed hello Eureka. So again, if I were to print this in different lines, it would print it in two separate lines. Now, hopefully you can see the usefulness of concatenation, of putting the comma and name, because what that does is it allows you to print on the same line, right? You can even add something. How are you doing today? Look at that, you made an entire prompt, already starting a conversation in Python by allowing to interact with the user. Isn't that really cool? Well, at least I hope you found that cool, because we have another example that might be even cooler. What you're doing here is you're taking a number, right? A variable called num, and you're setting it to int input enter number. Now, what is this weird syntax? Why are we just adding a lot of different random words around our code and surrounding it with parentheses, right? It's getting a little complicated, isn't it? Well, trust me, it isn't, okay? What an int means is just an integer, okay? An integer is just a number that's not a decimal and that's either positive, negative, or zero, right? So -2, -1, 0, 1, 2, 3. And why this is so useful, this function, is that it restricts the user to only enter a number. And you can see in this example that it's useful in this situation because we're asking the user to enter a number specifically. And if they don't enter a number, that's going to be a problem Because if you see on the line of code below, we are multiplying that variable by 5. And you probably can see now is that if you didn't restrict their input to an integer, right, what they could probably end up doing just for fun or just to mess with the system is enter a word or some random text. Now, unfortunately, Python cannot multiply text. It cannot do operations with text, right? You can't multiply a word times 5, right? That's just illogical. That just doesn't work like that, right? So that's why sometimes smart programmers use integer or the int function if they want to restrict input to just integers. Let's actually do that. Let's create a new code block. Okay. Let's do num is equal to int input. Enter a number. Okay. Now we're gonna have it print num times 5. Okay. Let's say we do 5. Okay, it's going to print 25. Great, 5 times 5. Now let's say we do hello. Oh no, value error. Why? Because it's invalid. You can see the error description here. It's invalid for an integer, right? You just simply cannot enter hello as a number, okay? Now say you didn't have it, right? That would be a problem. Sorry, let's rerun this. And look at that. What it did is it actually replicated his string 5 times. Now this is Python mechanics that's a little more complicated, but for now, what we want to understand is that it's illogical to multiply a number by 5. And if you're getting the user, if you want the program to eventually do something numerically, then this is not the effective way to do it without using an integer input, right? If you want to restrict the user to just integers, then you're going to have to put the int around it, just like this. One more thing to note is that by default, everything the user enters is a string or a bunch of characters, right? Or words, essentially, right? Even numbers you enter are taken in the system by strings. Like you can put quotes around those numbers, and that's how the computer is going to read them, right? So again, if you want to restrict your output, you're going to have to use the int function. All right, guys, and you already know what time it is. It is time for our very first project of this session. Now, this is going to be one of the simpler projects, of course. This is the basics of Python, but it is very important that if you want to get good at Python, if you want to follow along, then you even do the basics of the most basic projects with us, right? If you think this is too easy, that's fine. We still want you to get exposure. We still want you to learn. You have to start at these fundamentals before moving on. Okay, so as you can tell by this logo, let me turn on my very cool laser pointer. This is a calculator. So you probably have some indication now what we're going to be building. Wink, wink. A calculator, okay? We're going to be first designing a program flow of what we want to build, okay? In the calculator. Now, this calculator is going to have a very simple function. It is just going to be addition. If you want to add different functions, well, that's going to be a little more complicated, and that's a topic that you're only going to be able to do when you learn about loops and conditionals, right? Or primarily conditionals, actually. So that's going to be soon, not in this lesson. We're only going to carry out one operation here, and that's going to be addition. Okay? I encourage you to try out other operations on your own. So, actually, now that I think about it, I will go over all the operations with you. But first, let's go over the program flow. What a program flow is, it describes the way your program is going to run. For these simple programs, I mean, it's not necessary that you have to always write a program flow, but I will say mapping out the logic of your code is probably one of the smartest practices that programmers do, because if you jump right into the code, it's very hard to walk through your logic, right? You need to have something planned out before you jump in. You're of course going to have issues and you won't have a perfect plan, but it's always good to have some sort of plan. In this case, we will have a perfect plan because it is a very simple program. So how it's going to work, you're going to start with the user input, okay? In this input, you're going to ask the user for two different numbers, okay? System's going to process it. It's going to add both your numbers, and you're going to reach the output. Once you have the output of the sum, you're going to print it out. Step many beginner programmers usually forget. Just because you did the output, just because you did the addition, subtraction, multiplication, or division, doesn't mean you actually got it to print out. You have to explicitly write the print line for your compiler to know that you want to print it out onto it, okay? So, I'm going to give you guys a few seconds to think about it, pause this video, think, try to implement the solution on your own. It might seem complicated, but trust me, everything that we learned in this session is going to be used in this. Nothing more, nothing less. You're going to be using all the skills you learned in this session to do this. So trust yourself. Trust that you know that you have all the knowledge to create this project. Another thing that's very important for programmers is trust, okay? You need to have self-trust if you want to be able to code massive programs or programs of any scale. And we're starting at a small scale right now. So trust that you have the knowledge to do this. I believe in you guys. You pause the recording, and whenever you're ready, unpause, and I'll go over the solution. All right, you are ready? 3, 2, 1, boom. There's a solution, okay? Hopefully you were successful. If you weren't, it's okay. It's perfectly all right. This is a learning experience, and that's why we're here to guide you through the process. So first I'm going to walk you through it here, and I'm going to actually run it on Google Colab. So again, let's walk through this one at a time. What is Python? Python's a language that reads one line at a time. So we have to be strategic in our line placements. We're going to first place our first line that has num1 equals to int input what is your first number. Again, the input function essentially gives a prompt, what is your first number, and it gives a text box for the user to type in. We're wrapping it around an integer, right? This is best practice. Again, you don't have to do this for your program to run properly, but it's just ensuring safety. You want to make sure that the user actually enters an integer, and if they don't, the system's going to throw an error on them, okay? So that's why we're wrapping it around an integer, which is just a number, okay? So we're going to do the exact same thing for num2. But instead, of course, the variable name is different. Again, if you set both of them to the same variable, that's going to be a problem because it's going to replace it, okay? So num2 is equal to int input what's your second number, okay? And after you ask for the first and second number, we're just going to print it to the console. Remember our system flow? We print it out. So the output's going to be like this. What's your first number? 5. What's your second number? 3. And it's going to print 5 plus 3, 8. So let me copy paste the code over here. Num1, num2, print their addition. And so we're going to type a first number, any number. Let's do 30. Click enter. Second number, let's do 7. And I hope if this program works before I click enter, I'm going to predict that it's going to print 37 because 30 plus 7 is 37. And there you go. Boom, right? So what we're going to actually do right now is we're going to experiment with other operations. Common math operation. Now in math class, you hopefully learned the 4 primary operations. They're addition, subtraction, multiplication, and division. Now, you can probably guess what subtraction is going to look like. This sign, right? When you subtract 30 and 7, you should get 23. But the thing about multiplication and division is that they look a little bit different, okay? In your standard math class, you probably saw like, I don't know, like the dot. For multiplication, you have like the X sign. And for division, you have like this line, but then you have 2 dots, a dot above it and a dot below it, right? Now, okay, that's perfectly fine for math, but in programming, there's only one way you can represent multiplication and one way you can represent division, and they're completely different from math class, okay? For multiplication, you got to use this star symbol. It's right above the 8 on your keyboard. You click Shift 8 and it makes the star symbol. Okay, so let's try that. What's your first number? Let's do 2. And I'm going to do 5. 2 times 5 should be 10. Perfect. Sorry. And you can divide. Okay? This is the slash. This is the symbol for division. To me, it makes a little intuitive sense, because when you're dividing, you're actually writing fractions, and fractions have like a little line beneath them. This is really the only way the computer was able to understand division, and you're going to have to follow these rules and formatting if you want to be a successful programmer. So now we're going to try dividing num1 by num2. So let's go, num1 is 30, num2 is 5. When you divide them, you get 6, right? Perfect. Okay. One thing I did want you guys to know is that for math class, remember, you cannot divide by 0. So if you were to put 0 here, oops, 0 division error, you can't divide by 0. So luckily, Python is smart enough to know these things, right? It gives errors. And remember, guys, errors are not always a bad thing. Of course, they're annoying. Of course, you don't like them. But they tell you when something's wrong in your program, when you have to address something. Now, this 0 division error is something you can actually solve, right? You can stop this from even happening by checking if if the second number is not 0, right? But unfortunately, today's lesson limits us to just doing this. When you learn about conditionals in future lessons, you're definitely going to be able to make so many more complex programs that you probably weren't even aware of making right now. So yeah, that's all for this this project. All right, guys, thank you guys so much for attending the first session. I really hope this helped you a lot. I hope you walk out today knowing a lot more than you walked in with. Of course, that's always the goal. One thing I wanted to leave you with before ending this session is that practice is really important, okay? Now, of course, this is not like a school where we're going to assign you homework, but I'm going to tell you one thing. The one and number one way to grow in anything in life is to practice it. You probably heard practice makes perfect. Now, perfect, that's subjective. You can choose what perfect means to you, but I think practice makes progression. The only way you're ever going to improve is if you put in the time and effort to use the knowledge you learn in every class and make some sort of project. Think of anything, okay? You learned how to take user inputs, you learned how to print, right? What you can do is like literally ask the user anything and try different ways of adding things, of combining strings, of multiplying things, you know what I mean, right? You learned enough skills to make these little mini programs that can help foundationalize this knowledge that you learn. And so that knowledge can actually help you do better in future lessons because now you're not going to be struggling with previous lessons, okay? So practice helps with so many things. And I really encourage all of you to just practice if you're really passionate about becoming better. And with that being said, again, we're really thankful for whoever's here watching our sessions, taking the initiative to grow and learn. We hope to see you guys in our second session. The video will be uploaded shortly. Thank you.